Alright, we've been talking about geometric sequences, and so we talked about how those are exponential functions. So we're going to kind of broaden that out a little bit, and where we're talking specifically about those sequences, now we're going to talk about exponential functions as a whole. And so exponential functions are defined by an equation, and the equation is y equals a times b raised to the x power. Okay, and I can put that in both spots here, where a is a factor or a scale for the equation, and b is also is our ratio for this function. So if b, this value right here, b, is greater than 1, then the function is an exponential growth, and it is increasing. If it's less than 1, then it is exponential decay, and it is decreasing. Okay, so those are the two main things that we need to know about exponential functions in Algebra 1. You'll get more into these in Algebra 2, but for now we just need to keep in mind that if that value right here is greater than 1, then it's exponential growth, it's increasing. If it's less than 1, so a fraction like 1/2 or 3/4 or something along those lines, then the function is an exponential decay, and that means it's decreasing. Now, there's another term that we have discussed in class before, but it's called an asymptote, and it is a line which the graph gets close to but never touches or crosses. Okay, so we're going to just kind of walk through a few examples of what these look like. So we're going to start with number 1. It says to classify it as exponential growth or decay, create a table of values and graph it, and then identify its key characteristics. So here, the number that x is being raised to, or the power of x, is attached to the number 2, and that number 2 is greater than 1. Okay, so this is going to be exponential growth, and it's going to be an increasing function. So let's create a table, and I'm just going to pick some x values randomly, and we're just going to do -2, -1, 0, 1, 2. And now I'm going to take these values and I'm going to plug them into the calculator, and I'm going to do 2 raised to the -2 power. So if I were to put in 2 raised to the -2 power, my calculator tells me that the answer is 0.25 or 1/4. If I do 2 raised to the negative first power, I get 0.5. If I raise 2 to the 0 power, or anything to the 0 power, I get 1. If I take 2 and raise it to the first power, I get 2. And if I take 2 and I raise it to the second power, I get 4. Okay, so just using my calculator to create those values. So now I'm going to plot those points. So I have -2 and 1/4, so it's a dot about right there. -1 1/2, dot about right there. 0, 1, 1, 2, and 2, 4 creates this line that looks like a curve, and it goes up, and it's going to continue up in that range. Okay, so our domain is going to be all real numbers. It's going to continue to the left and up and to the right forever. The range is going to be everything above this asymptote. So it's going to be everything greater than 0. Okay, I'm never going to cross that line right there. Okay, I'm never going to go below the x-axis. And so that means that our asymptote is at y equals 0. So everything above that is our range. And then the y-intercept is where it crosses the the y-axis, so that is at 0, 1. Okay, so just very basic information about the exponential functions, but just to kind of give you an idea of what those look like. We're going to do, let's do one more example.